Hello everyone. Today we are going to introduce our study about environmental control system. The spread of COVID-19 has been a problem in recent years. COVID-19 can be prevented by ventilation, so we develop a system to ventilate rooms remotely or automatically. To further improve the prevention of infectious disease, we also needed a function for logging the dates and times when infectious disease outbreaks are likely to occur. This research aims to implement a special IoT system that measures and controls the air environment of a room with ESP32 and infrared communication. Our environmental control and observation system transmits measured environmental data to Ambient. Ambient is a cloud service that can receive, store, and display measured data as graph. And the system can also control the environment externally via the internet. Users can control the air environment with clicks of a button using a terminal equipped with a web browser. We built devices with ESP32, BME280, CCS811, ambient, and infrared LEDs. The ESP32 is a microcomputer that can connect to several sensors and can be connected to internet. The BME280 measures temperature, humidity, and air pressure, and the CCS811 is a sensor that measures CO2 concentration. In this control system, ESP32 acquires environmental data when users access a web page or click a button on the control screen. However, if users do not take any action, the system automatically retrieves environmental data every minute. ESP32 updates the control screen and sends an infrared signal to the air conditioning equipment in response to the action. The operation is shown below. Clicking the on button turns on the circulator behind it, and clicking the off button turns off it.
This control system has an auto-control function to maintain a constant room air environment. The function automatically operates the air conditioning equipment when the predefined environmental data values exceed or fall below the thresholds we set in advance. After clicking the control button, click the Set button to update the control screen. In this video, to prevent the CO2 concentration from rising above 1000 ppm, the circulator is turned on if the CO2 concentration exceeds 1000 ppm and turned off if the concentration falls below 1000 ppm. We verified that the completed system meets our objective. First, these sensors can measure air environment data. Range of measurement is shown on the table. The figure also shows how the air condition of the classroom changed by ventilation. Environmental data of August 8 classrooms obtained by using this system are shown. On this day, at just 12 o'clock, the student came back to the classroom after taking a physical education class. Ventilation began soon thereafter, so the CO2 concentration quickly decreased. In conclusion, the device worked properly, realizing a comfortable environment and graphing environmental data. This means that the system can contribute to the prevention through two methods: environmental management, monitoring, and measures to prevent infectious diseases.